Hello friends, it's been a while. Today we're going to build an AO29 amp, and basically an AO29 is just a part of a Hammond organ from the 50s or 60s that can be converted into a killer guitar amp. It's really long as far as the chassis goes. Well, let me get it. AO29's really long. It's kind of like a tweed chassis. In fact, it's about the same length as a Tweed Twin. Some people, to save time, utilize the existing circuitry, but I'm going to gut most of it and put in my own wiring, my own filter capacitors, etc. If it were a smaller Hammond AO, I may consider leaving some of the circuitry. Let me show you a smaller one. So, yes, this is an AO44. By comparison, you can see how tiny that is. But the output transformer is really beefy. It might be beefier, in fact. This will run EL84s. This should be a pretty fun project. I've already done one, but I had over 3 hours of footage to edit down, so I never got the video out. I might get it out in the future. But it was a hell of a learning experience. So we have the schematic, we have the layout, and that's about all we need. Alright, so I think I'm going with the beefier transformer here. This one's in really good shape too, the sockets. I mean, this looks like it was well kept. Alright, here's a better shot of it. So I'm going to use Soviet tubes. The tubes I'm going to be using are 6P3S, the 6L6 equivalent, or more so, the 5881 equivalent. So we may be able to use this bigger power transformer for the 6L6. My prior build had 6V6, which I know can handle voltage up there too. We're going to see how the 6P3S work here. We're also, instead of 12AX7, going to use 6N2P, which will require a slightly different filament wiring configuration. And yeah, because you can get 6N2Ps for dirt cheap, and 12AX7s are going to cost you, at best, $14 a tube. So, Soviet tubes, we're going to try. We're also going to have a 12AU7 phase inverter, a 12AX7 all-tube reverb circuit, which is going to be cool. I designed this circuit using 3-triode reverb, and it works really well. So first things first, we're going to gut it. You can see all that. You can see this apparatus must come off. This needs to come off. These power strips need to come off. It's going to be some drilling and screwing, which is always a lot of fun. Alright, it is gutted. It's a new day, by the way. This took quite some time. What I do is I don't desolder every single wire. That would take eons. So really what I'm going to be doing is working around the existing wiring on the board. Now the other board was more of a turret strip where it was easier to get things out. These wires are wrapped several times around. So after about an hour or two of pretty dodgy work using this existing board, I've decided to stop before I get any farther and order a new board, because this is just ridiculous. Alright, so I came up with a creative solution, because if I use regular turret boards and lay them flat, there's some obstructions here, such as the transformer. We could easily take this out, but having the boards vertical like this will be the best solution for this build. Now, it's not going to look great, but it's going to sound great. So we're going to do that with each board, and it should be much easier than trying to rip all of the old solder and wire off of these old tabs here. Alright, here's where we are with this thing. The wires are much too long, but I leave them that way until I know exactly where each wire needs to go. Of course, I did create a layout based off the schematic, so this has been really helpful. And right now I am getting the chassis prepared, and one of the things I had to do was actually drill the old power cord out, and you can see the white fluffy stuff inside there. I'm pretty sure that's asbestos, so if you do drill the cord out like I did, be wary. Don't breathe in or wear a mask, even better. Alright, so now what I have to do is clean off the pins that I'm going to be using for each tube socket, because they all have their old wire wrapped around, and they really made things to last back in the day, I can tell you. Alright, so I'm about to install the new strain relief. I'm actually going to keep the old power cord hole. I used it for my last build. The way you install one of these is you screw off the back, and then, okay, that works. Should fit right in there, as you can see. And then I just screw the little fastener on here. And you could also do it the other way. And then you put your cord in and put this on, and then twist it until the cord is nice and snug. Also, a tip is with the power transformer, leave everything wired that you can unless you're certain of what it is. So right now I know that these are the heater wires, 5-volt heater wires. This is where the B plus was. These are your high voltage. This green one is your center tap and will be grounded. These two black ones are your primaries. And then this guy right here was actually for the field coil. Just use old computer cords. You can get them for like $2 or $3 on eBay. I think you can even get them from Goodwill. I've heard. And basically you just cut off the head and then strip it appropriately. Alright, so it's coming along. I've got the switches and fuse holder put in, and the transformer primaries hooked up to the cord, and a grounded the center tap along with the safety ground. So yeah, and then I'm going to use this little bus over here as the ground bus, which is unusual, but it worked with my last build, which was also an AO29. I did break one of the pins off of the ancient socket, so I put a new socket in. Alright, so the amp works. I got it working. It sounds really good. Of course, with terrible lead dress like this, you're going to get some parasitic oscillation. So, even though I followed the layout to a T, I did not consider what was the most efficient way to place my components so that lead length is not excessively long. So what I'm doing now is I'm replacing specific wires with shielded coax. And the way I pick the wires to replace is I turn the amp on and I turn the volume all the way up, and I find I use a attenuator, and I lower the attenuator volume so I hear the oscillation. I hear the squeal. When I hear the squeal, I can move the wires around and see which wire affects the squeal. It'll lower the pitch of the squeal, and it may even eliminate the squeal. And then I'll replace that specific wire with coax. I anticipate replacing a lot of these with coax, or at least cleaning it up a bit so that these leads are shorter. But anyway, the reverb circuit is untested currently, and the tremolo circuit does not seem to function. So we'll be troubleshooting that in a little while. But right now, we're going to do the basics, get rid of the oscillation. Another thing you can do to get rid of the oscillation is to use grid stopper. A value of 3.3K or 2.2K is a good value to start with without attenuating the signal too much. So I often put grid stoppers on even my preamp tubes that have this parasitic oscillation problem. In the future, I'll probably flip the board horizontally and get some really long standoffs for it. Probably use a different board than this, and I think that will help clean it up a little bit. Alright, we just installed this guy, so let's hear what it sounds cranked on the attenuator. I did have a voltage meter on there so I could see when the tubes would warm up. If it squeals, we've still got problem. Ah, there we go. Alright, so right now that's about as high as the amp will go. You can hear that there's still some squeal. So let's move these wires around. You can hear the pitch changes. It's not as bad as it was though. Not as bad as it was. This guy right here, he's sensitive. So I think we're going to replace this guy right here too. Alright, this wiring nightmare is done. It's been the first tremolo unit that I've created. And the tremolo is just kind of lackluster. It really doesn't have enough depth to it. It's a 6AU6 tremolo. And I have lowered the value on the schematic that's recommended to be lowered, which is, if you can see it, this 1 meg right here, I've lowered it all the way to 22K, and it still doesn't have much oomph to it. But at 1 meg you could hardly hear it, so better than nothing, I guess. If you guys have any ideas on how to soup up this tremolo circuit, please let me know. But yeah, right now we're going to install a pilot light, and I go cheap on the pilot lights. So you can get a bunch of these for like 10 bucks on Amazon, and they're all different colors. And so we're gonna, last one I chose was blue for my amp, so we're either gonna choose a green or red. So for this pilot light, we're just gonna take a 470K ohm resistor, and we're going to attach it to the third node here, and that should give us enough voltage drop to not allow the LED to work. And that's the cheapest pilot light you can get, and it looks cool and is totally effective. Alright, so the amp has actually been finished for quite some time now, and it works well. I'd say the thing that works a little bit not as well as I'd hoped is the tremolo intensity. But anyhow, everything else seems to be working great, and the tone that comes out of this thing is just unbelievable. So look forward to doing the demo at the end once the cabinet is built. So we're going to build a rustic cabinet with a gold plexi control panel, and it's going to look very rustic and kind of beat up, and it's going to be good. I'm looking forward to it. So. Eating grass. Interesting dog. So we're going to try to cut this at 21 inches and then cut a 2-inch section out of it, and then spray paint it, and then apply it to the amp face. Drill all the holes and then apply it with some glue and perhaps some rivets. Alright, so now I'm going to clip it with these welding clamps. I'm going to take a Sharpie and go on the inside and poke and outline where the holes are. Alright, so what have we learned today? We've learned that the aluminum flashing is acceptable, but it's going to be flimsy, so make sure your holes are cut to the right diameter. Acrylic is out of the book. There's another type of plexiglass, but it was like $30 a sheet, so I'm good on that for now. I do think it would work. It's I've used it as a replacement window in my school bus, and it works just fine. It's durable. You can bend it. It doesn't snap. It doesn't crack. So that's what I'll be going with next time, I think. But hopefully this aluminum flashing will fool everyone into thinking that it looks decent. We will see. I do need a deburring tool. Now the other thing I tried here was the brass roll, and the brass is a stronger material, when I tried to use it with the Christmas tree bit, it did that. So I might, this would be the ideal material if I could figure out how to drill through it without the burring occurring, because it's extensive burring. Anyway, that's where I am right now. I'm starting to sand this old cabinet I did. This was a like a factory second cabinet, if you will. And I'm just now getting around to sanding it and treating it. We're going to paint it carbon, or stain it carbon gray. And we're going to have a normal burlap grill cloth. So this thing's going to look real rustic and really unique. I'm going to use some old CTS 8-ohm speakers I have as well that I got for $25 a piece. And I'm excited about it. And we are cleaning this cabinet up, getting it ready for staining. Just need to put the baffle supports in there. And then we'll be able to stain it carbon gray. I was thinking, what do I have that's less diameter that would give me more screw area here? And these dog balls. And these dog balls will be able to sit in there just so that the speaker, you know, will still have plenty of room to do its thing. You know, we'll still have plenty of room to amplify. So we're going to see how that's going to work. My brain has gone down a lot in processing power, so I'm going to use the last moments I have tonight to get this cabinet stained carbon gray. It's a pretty handsome carbon gray, and it's going to have a burlap, blonde burlap grill cloth, which I think is going to look pretty good on this. And I'm slowly applying the polyurethane and mixed with mineral spirits, but I'm a little rusty, so catching up on that. So that's drying now. The bottom still needs to be stained, but the rest of the poly's going on. And now it's getting exciting. Looks pretty good. Not perfect, but pretty good. And we are going to go ahead and trace out where the amp needs to be mounted to the backboard, and then we'll be one step closer. So I haven't filmed in quite some time, but the project's coming along quite nicely. The AO29. Not perfect, but I don't know, it looks pretty good. Definitely made some mistakes, and looking forward to hear how it sounds through these speakers I got for $25 a piece. Now these speakers are PA speakers. Sorry for the vertigo there. And they are 8 ohms a piece, and the transformer is apparently 8 ohms as well. So what I have to do is link them in series to do an impedance mismatch at a higher impedance. Shouldn't be harmful to the output transformer in that case. But yeah, looking good. Alright, so how do I make my speaker cords? I pretty much take a shitty Chinese cable. I cut it as short as possible because, of course, the wire in this cord is not rated to be a speaker cable. And then I replace most of the cable with a thicker gauge. And wrap that thicker gauge, splice the thicker gauge to the thin gauge, and then I mostly have a nice thick speaker wire, except for this part. And then I just solder these clips, speaker clips, to the end. So when we're finished with it, we have very little thin gauge wire, but most of our run is going to be of adequate gauge for the amplifier. And there's the final product. It works well, from my experience. Well, folks, there she is. We're using a 12AU7 as the phase inverter. We're using a custom reverb circuit that's driven by a 12AX7. And in order to cut some of the high end or feedback you can get, there's a small like 100 picofarad capacitor between the plate and the grid on the reverb driver. So that's kind of interesting. This thing can get out of hand though, so like if you turn the treble all the way up and the reverb all the way up, you're going to get some serious feedback. But it's also very versatile. You can get a lot of tone on this that I can't on some of my other amps. Good morning. So the amp is finished, and I must say it came out quite nicely. I don't have any labels for the knobs yet, but the knobs match the wheels. The handle is a dark blue. Finish is a carbon gray. Now these speakers are wired kind of upside down here just because there's some tubes up there. You can see the rectifier and the 5881s. I guess they're the Russian equivalent of 5881s. Pinout is exactly the same, and they're biased pretty cold to not heat up so much, so there's plenty of ventilation there. And our CTS speakers, which these things really are freaking amazing. I was not expecting them to sound this good. So one thing might do is make just a tiny cutout here to increase ventilation, but right now it's sounding and it's playing good. So let's hear what it sounds like. reverb circuit is a custom circuit. Its inspiration was taken from a Ampeg Gemini. It is a transformerless circuit and powered by a 12AX7 in the front, which really packs a punch, and it makes a $25 reverb tank this big sound like, I mean, the dwell is, it's incredible what you can get with this tiny reverb tank. Let me show you how. Look at that tiny little reverb tank. All that reverb coming from that custom circuit and that tank. I think it's a winning combo. Alright, well, this concludes the demo of the LHR rugged amplifier number 1. More to come. I have many more Hammond AOs to modify.